सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं रिगार्डिंग टू केमिस्ट्री एज ए केमिस्ट्री वाला चैनल। प्रीवियस वीडियो में हमने डिस्कस किया रिगार्डिंग टू द जस्ट प्रिपरेशन मेथड्स ऑफ हेलोएल्केन। नाउ द टाइम टू डिस्कस अबाउट द second part, that is the preparation methods of haloarine. So these are the preparation methods of haloarine. Haloarine. If we will go with the preparation methods of haloarine, then first of all it will be just by direct halogenation of arene. You can say arene or benzene also. This is very important reaction. Let's see how it is important. This is the benzene. If you want to get just chlorine and bromine derivative, then you can use, this is the Cl2. If you want to get just bromine derivative, then you can use over here just benzene and Br2. For the formation of chlorine derivative, you can use as a Lewis acid AlCl3 aluminum chloride. Why it acts as a Lewis acid, I'll explain you. And here you can use FeBr3, again your Lewis acid, because both exist in complete octet. So here will formation of chlorobenzene. This is the chlorobenzene. It was also in the chemical properties of benzene in 11th standard. This is the HCl. Now for the formation of bromobenzene, this is the bromobenzene Br, as a here will removal of HBr. If we will go with the just reaction, this is the bromobenzene. If we will go with the reaction, then this is called as electrophilic substitution reaction. As you know, there are three types of the substitution reaction. One of the nucleophilic as a SN reaction, another is your electrophilic substitution reaction, and another third is your free radical substitution reaction, which we have discussed in the previous video regarding to just alkanes as a halogenation of alkane. So this is the electrophilic substitution reaction. If we'll go with the mechanism, it is very important. Mechanism, then it exists three steps. In the first step, first of all, it will react. If we are going to take just AlCl3, then here will Cl2. This is the AlCl3. So here will formation of, due to presence of Lewis acid. Why this is acts as a Lewis acid? You can listen it and you can understood it over here. If we'll go with the AlCl3, then it exists only 6 electrons in the outermost shell like this. Electron deficient species, and according to Lewis, these acts as a Lewis acid. Again, FeBr3 is also as a Lewis acid. You can see there are 6 electrons in the outermost shell. So these two species acts as a Lewis acid, and most of the just electrophilic substitution reaction exists the presence of Lewis acid. So here will formation of AlCl4 minus as a electrophile. Here will formation of Cl plus. If we are going to take just a bromination, so this is the bromination. Regarding to bromination, we can use Br2. This is the FeBr3. Due to presence of FeBr3, same. Here will dissociation of bond as a heterolytic bond cleavage. So here will formation of FeBr4 minus plus. This is the Br plus. So here will formation of the two species as a electrophile. Now with the second step as a chain propagation step, this is the benzene. With the isolated form of the hydrogen. If we are going to take, then suppose just chlorination, then we can use Cl plus, and for the bromination you can use Br plus. So here will transition state like this. This is the benzene, partially H and partially, if you are going to take chlorination, then here will Cl plus, and for the bromination you can use here Br plus. So valence of the carbon is 5. Now it dissociates. If you are going to take just chlorination, then here will presence of Cl, and if you are going to take bromination, then Br, and rest it will be removal of H plus. In the chain termination step, what will be? This is H plus. If you are going to take just bromination, then here will formation of AlCl4 minus. So this is the AlCl4 minus. So here will formation of AlCl3 as a device acid as a catalyst, and rest it will formation of HCl like this. And if you are going to take just bromination, then here will formation of FeBr4 minus. Here will formation of your FeBr3, and this is the HBr. So this was about the mechanism, and here's the attack of electrophile. This is the most important electrophile. This is your electrophile, and due to attack of electrophile, this is called as electrophilic substitution reaction. And here will formation of chloro or bromo benzene. Chloro or bromo benzene. This is the just first reaction by the direct halogenation of the benzene or arene, and these gets again free, so acts as a catalyst. And this was about the Lewis acid. So this was about the first reaction by direct halogenation of benzene or arene. Now the time to discuss about the second reaction. What is that? Listen me carefully. Regarding to preparation methods of haloarne. And this video is also important because of it will help you in a lot of matters. So get ready. And from today onwards, I'll upload just 2 to 3 videos regarding to this chapter, which will be convenient for you. So this is the second reaction. This is the second reaction by side chain halogenation. By side chain halogenation. For this, chlorination will be very convenient. Suppose you have alkyl benzene, and if there is Cl2, then by free radical substitution reaction, it will formation of benzyl chloride. It is also question of interconversion. This is the benzyl chloride. Remember one thing, and it will be just your HCl. If Cl2 is in excess, if Cl2 is in excess, then what will be? The forming benzyl halide will be as follows. Here will formation of dihalogen, trihalogen substitute also as a Cl2. This is the Cl2 with the same presence H mu. First of all, it will formation of disubstituted CHCl2, and further on reaction with Cl2 in the presence of same H mu photon, it will formation of like this trihalogen derivative CCl3 with the removal of HCl. This was about the just chlorination. If we want to get just chlorination only one time, we want to get just only benzyl chloride, then we can use. It is also possible. It is also possible by sulfuryl chloride. Sulfuryl chloride also. How? Then we can go C6H5. This is the CS3. This is the SO2Cl2 sulfuryl chloride. Here will formation of C6H5 CS2Cl. This is again the structure of benzyl chloride, and here will removal of SO2 with the release of one of the HCl. We can say this is the pure method of the formation of benzyl chloride. This is the benzyl chloride. So this was about the side chain chlorination. If we want to get further, this is the very important. If we want to get further, then you can use just for the bromination. For bromination, it will use of again NBS. This is the most important reagent. NBS means N-bromo succinimide. The structure, this is the C6H5, this is your CS3, as a, you can say toluene also, or methyl benzene. This is the methyl benzene as a IPAC name, and you can say toluene also, toluene. So as a toluene, this is the C6SiCS3. Here is your N-bromosuccinimide, CS2. This is CO and CO. This is your N, and this is the Br. This is the minus also, NBr. If we'll go with this reaction, then in the same presence of peroxide, less amount of the peroxide, and with the presence of light, here will formation of C6H5 CS2Br, as a benzyl bromide. This is the benzyl bromide, and rest it will be formation of succinamide, CS2 CO. This is the CO, and this is your NH, succinamide. So this was about the just formation of halogen derivative by side chain halogenation of the haloarine. Now the time to discuss about the third reaction. Before taking third reaction, you have to go with the name also. This is the benzyl dichloride, and this is also called as benzo trichloride also. So these are the name of the forming substance. Now the time to discuss about the third preparation method. What is that? Listen me carefully, and it is too important also. What is that? That is your, you can say, by diazonium salt. It's too important because of it will be a lot of naming reaction also. So we will take two partition regarding to this. This is the 1 and 2. First partition is your third reaction from diazonium salt. If you will go with this reaction, then you have to take this aniline. This is the aniline, and how we can get just diazonium salt. First of all, we'll go with the aniline. It is also called as benjamin aniline or benjamin. First of all, it will react with the just NaNO2, NaNO2 plus 2 part of HCl. We can write them as follows as a HCl. Temperature will be 0 to 5 degrees Celsius. Super cool condition, or you can say 273 to 278 Kelvin temperature also. So it will removal of Na plus and one of the Cl minus. This is your NaCl. Here is the two hydrogen and two of oxygen. So it will removal of water molecule as a 2 of S2. Rest it will be one N, another N and one of the Cl. So it will be your N double bond N. This is the Cl. It is also called as BDC, means benzene. Here is the BDC mean is benzene diazonium chloride, BDC, the meaning of BDC. You can take this reaction by indirect method also, and now this reaction, it is again important reaction as a naming reaction. It is also called as diazotization reaction also. Diazotization reaction also. It will be naming reaction in this chapter and further also. So this is the diazotization reaction. This reaction may can take just indirect method also. By indirect method, first of all, we'll take just NaNO2. NaNO2. This is the just your one of the HCl. Dissociates as follows. So here will formation of HNO2. This is called as nitrous acid. Nitrous acid, and rest it will formation of NaCl. Now we can take aniline again because we are going to take indirect method. This is the NS2. Here is the formation of nitrous acid. So this is the HNO2 as follows: ONOH, and this is the HCl. HCl. As I told you, you can write it as follows because it don't have proper space. HONO, nitrous acid, HNO2, and this is again molecule of HCl. Temperature with the same 0 to 5 degrees Celsius. So what will be? Here will removal of one of the S2O. Here will removal of another S2O. So here will formation of the 2 of S2O, and rest it will formation of BDC. BDC, and this is the another way to represent the diazotization reaction. This is the BDC, benzene diazonium chloride. Now, how we can get it? This was about the diazotization reaction. You can write either as follows or as follows, and this is the aniline. Now the time to discuss about how we can get haloarine from the BDC. So this is the BDC. This is the BDC and double bond NCl. If suppose you are going to take cuprous salt as a CuCl, or you can write them Cu2Cl2 also, oblique HCl. Here you can use Cu2Br2 or CuBr, oblique HBr. So what will be? Bond cleavage will be as follows. Here will removal of N2. This is the removal of N2. Here will removal of one of the just Cl का common ion effect काम करेगा. So Cl will be over here. In that case, it will formation of chlorobenzene like this. This is the Cl, chlorobenzene. Chlorobenzene. If you are going to take just this is the BDC, just cuprous bromide, then it will removal of HCl. It will removal of HCl, rest removal of N2, and it will substitution of Br. So what will be? Here will formation of your bromobenzene. This is the bromobenzene, And if we'll go with the reaction, then these two reactions are known as, very important, these are known as, very important naming reaction, as a Sand-Meyers reaction. Sand-Meyers reaction as a naming reaction regarding to this formation of chlorobenzene and bromobenzene. One thing is also, from this method yield will be very less. So what we can say here, may we can use here may use of CU powder also, in spite of just you can say cuprous halide. So the reaction will be as follows. This is the BDC. This is the BDC. Here are the two conditions. We'll take copper oblique HCl. We'll take copper oblique HBr. HBr. Here will removal of the same product N2. Here will removal of same byproduct as a N2 and your HCl. Here will formation of chlorobenzene. This is the Cl chlorobenzene. This is the chlorobenzene, and here will formation of bromobenzene. This is the bromobenzene. Br. Bromobenzene. Bromobenzene. If you want to go with the reaction, then now this reaction is the another naming reaction which gives more yield of the chlorobenzene and bromobenzene. Now this reaction is called as Gattermann reaction also. Gattermann reaction as a naming reaction if we'll use of copper powder in spite of cuprous halide. Now the time to discuss about the just formation of iodobenzene and fluorobenzene. So we can take as a over here for the iodobenzene and your pet and favorite fluorobenzene. Both are very important. And all of these techniques are laboratory method, not commercial. So for iodobenzene, here is for iodobenzene, what will be? Here will use of, you can say, this is the BDC, this is the BDC N double bond NCl, and this is the Ki, or you can use NaI also, sodium iodide or potassium iodide. Then here will use formation of iodobenzene. Here will use formation of iodobenzene as a I with the removal of N2, and just if you are using Ki, then it will be KCl. For NaI it will be NaCl. So this is the removal of N2 and this is the removal of KCl. This is the KCl or NaCl, and here will formation of iodobenzene regarding to just same reaction. If we want to get just fluorobenzene, for fluorobenzene, then it will use of fluoroboric acid. Fluoroboric acid will be used. How? This is the BDC. This is the BDC N double bond N Cl. This is the fluoroboric acid HbF4. By the removal of HCl, first of all, it will change in it will change in one of the important another BDC azoonium salt, that is called as benzene diazonium, benzene diazonium tetrafluoroborate, tetrafluoroborate. If we'll heat किया, then what will be? Here will be dissociation of N2 bond, removal of N2. Here will removal of BF3, and rest it will formation of fluorobenzene like this. This is the F, fluorobenzene. If we'll go with this reaction, then this is again your naming reaction. As I told you, this chapter is very important. So this reaction is called as Balch-Schiemann reaction. Balch-Schiemann reaction. So this was about the just your third reaction from BDC. Now the time to discuss about the fourth method with the same. What is that? From silver salt of carboxylic acid. Silver salt of carboxylic acid. So this is the fourth reaction by silver salt of carboxylic acid. This is also called as same Hunsdiecker reaction. Hunsdiecker reaction. It is also called as Borodin-Hunsdiecker reaction. Borodin Hunsdiecker reaction. Decker reaction. It is again you can say carbon degradation reaction. It is also called as decarboxylation reaction. Here will removal of the carboxylic group. So this is the best way to degrade the carbon. So this is the silver salt of carboxylic acid as a benzoic acid. So this is called as silver benzoate. Silver benzoate. For this we can use Br2. Here will the presence of CCl4. Now it will formation of bond cleavage will be as follows. So here will formation of bromobenzene. This is the Br. Bromobenzene, and rest it will be formation of CO2 and your AgBr. So this was about the just from silver salt of carboxylic acid. Now the time to discuss with the fifth method. This is also called as commercial method of haloarne. Commercial method, it is also known as, it's a naming reaction again, it is also called as Rushig process. Rushig process also. What will be? Here we will use just your benzene. This is the 2 molecule of C6H6. Here will use of 2 of HCl. Here will use of O2 in the presence of cupric chloride CuCl2. What will be? Here is the removal of one hydrogen from two species. It will be removal of two hydrogen. So what will be? 2 molecule of C6H5Cl chlorobenzene with the formation of 2 of H2O. 2 of H2O. This is the benzene, and this is the commercial method also through which we can get just chlorobenzene at a large scale, and this is the Raschig process. It is also used in different kinds of the entire conversion reactions. So we will meet in the next video. Till then, shukriya, धन्यवाद. यही like और subscribe करते रहिए. I'll give you a lot of matter. Thank you so much.